Hi everyone, this is Tiffany. In this video, we will talk about double free vulnerability. Recall that in the last week, we talked about use after free vulnerabilities. This is the overview of use after free. Essentially, use after free vulnerability happens when a chunk after free is used again. So attackers can leverage the vulnerability by adding the heap metadata inside the free chunk. For example, if there is a free chunk, and then if the chunk is used by attacker, the attacker can change the next chunk linked in the free chain, and then change that to a victim object. After that, attackers can do two times of malloc. The first one is associated to the one that we added the chunk, and the second one is associated to the victim object. In this way, attacker will be able to control the victim chunk and then do arbitrary read, write, and then arbitrary execution. Now let's consider the scenario that when a chunk is edited, we will first check if the chunk has been freed. And if chunk has been freed, we will not allow attackers or any users to change the content of the chunk. For example, suppose that we have this act edit function, which is the one that I used for editing chunk. And here, before we edit the chunk, we're going to check if the pointer has been freed. So we're going to track the pointers freed or in use, and if the pointer has been freed, we're not going to execute the rest of the operations. In this case, can we still manipulate the layout of the heap, especially for those that are freed and saved into a T-cache? Turns out, yes. And especially, you can do that by freeing a chunk by twice. This is a very interesting thought, because originally you may think that, free a chunk is nice, and then you free it twice, it just means that you're double safe. But actually, it's not. Freeing a chunk twice will not, make the chunk safer, but actually bring in a vulnerability. So let's take a look at how the attack for double free vulnerability works. I'm going to show the diagram of Tcache on the left, and then show the steps for, attack that attacks double free vulnerabilities. So the first step is we're going to free a chunk, and then we're going to call this chunk 1. Second, let's free this chunk again. Unfortunately, in glibc 2.27, if you free the chunk for twice, it will not check if the chunk has been freed before. So in this case, both chunk 1 will be linked into the Tcache bin, and they will point to each other. And if you look at the chain of Tcache bin, you will find that chunk 1 is pointing to chunk 1 again. And in fact, this part will not happen because, as we showed before in terms of the metadata of a free chunk, we will change that information so chunk 1 will only point to chunk 1, and then chunk 1 will not be able to point to other places. In the third step, we're going to malloc a chunk with the size of hex 20, and in this case, chunk 1 will be used for the new mallocation. And then next, we can add the chunk that we just allocated, and then we're going to put the victim value, the victim pointer, to the place of the content of the chunk 1. So we're going to write the victim pointer over here. And then if you look at the diagram, or if you just use like beans or Tcache beans to investigate, you will find that right now, if you look at the Tcache bean, you will find that chunk 1 links to a victim object, which is the pointer, and also which is the content that we put over here. Finally, we're going to use the same trick from use after free, which is malloc first, which is do 2 times of malloc, The first one will malloc chunk 1 again. And then the second will help us to get victim object. And starting from a victim object, we can do arbitrary read-write. Also similarly, starting from arbitrary read-write, we can convert that to arbitrary code execution. We can use arbitrary read-write to overwrite the got table, to overwrite the saved return address on stack, or overwrite a function pointer, or overwrite the glibc function. So all those are different kind of hacks that you can convert an arbitrary read or write to an arbitrary execution, and especially those for arbitrary write. Arbitrary read will help us know the base of the libc so that we can arbitrarily write the location with the right value correctly. And finally, from arbitrary execution, we can execute malicious code, such as a winning function, shellcode, or rob chain. And which type of attack that we want to do is determined by the current situation of the binary. So if you do checksec, you will realize whether NX is available or if PIE is enabled. If NX is enabled, then it means that you cannot put shellcode over there because you are not able to execute stack. And then if PIE is enabled, that means that you need to get a base of libc first. And then every time you run the process, every time you interact with the vulnerable service, you need to get the base of libc again because the base of libc will be changing. Also, if PIE is enabled, the malicious function's address will be changing too. So here, make sure that you use checksec, this command, before you decide what kind of attack that you want to launch. Now let's program the attack of double free together. I'm going to reuse the original source code that we had before. Other than that, I'm going to add this statement for checking if the pointer has been freed before editing. So in this case, we will no longer have use after free vulnerabilities. However, since you're already familiar with this code, you know that there will be still double free vulnerabilities. So if I run it over here, you will see that those are, the same command coming from the menu, and you can choose what you want to do. And you can also reuse the utility code that you wrote before, as I show over here. The malloc, the free, the edit, exit, all those interactive utility functions. So again, what we are going to do is to write this part of the code, launch attack. I'm going to remove this, and then let's work on this together. So remember that what we need to do for double free, we need to first, create the scenario that there's a chunk that is freed for twice, right? So what we need to do is first we need to allocate a chunk so that we can start to free it for twice. I will put it allocate. And then here, for the size of the chunk, it is okay as long as the size of the chunk will not be greater than hex for 10. So I'm gonna put these size to still make it hex 20. And here, if you look at the alloc function, here I just use malloc 8. But you can actually change it to whatever value as long as the malloc the returned chunk size is no greater than hex for 1, 0. When you allocate a chunk, you can when you allocate a chunk, you can make the chunk with the size of any value that is smaller than hex 400 because that is the maximum available value for Tcash bin. Because if you are asking a chunk with the size of hex 400, it will actually convert that to 410. And then that is the maximum value for Tcash. And later on, we will talk about the other chunks that with greater size. But in this case, for Tcash double free, we're going to make the chunk smaller than hex 400. After we allocate a chunk, now we need to free it. And we need to free the chunk for twice. So I'm going to draw the diagram on the left for you to, have a good mapping between the diagram and the steps that we're going to do. So here, after the third step, we will have, in the Tcash bin, say this is 20 or whatever value, and we're going to have chunk 1, 0.2, chunk 1. So the next that we need to do is to added this value, but we need to malloc first. And after we malloc, which is going to be the first step, right? So after we malloc, we are going to have this chunk 1, and then we want to add it chunk 1 to point to victim. And if you still remember last time when we talked about use after free, we make our victim as a function pointer. We make our victim as a function pointer, which comes from the global offset table. And specifically, we make malloc as the victim function. So we want to change the got table of malloc to win function. Okay. So after that, I need to malloc the chunk again, and then added the content of the chunk to victim, which in this case, it should be, the got. So that will be the got table with the value of malloc. After that, similar to used after free, we need to do 2 times of malloc times 2. And then for the second time of malloc, we will get the victim object. So we want to change the victim object, that value equal to the symbol of main. The symbol of win. All right, now we have a pretty clear steps, and all we need to do All right, now we have a very concrete steps. And now we're going to use the actual Python code to execute those steps. So first thing that I'm going to do is malloc, as I said, and then free the chunk. So I am going to do free, and then here the chunk is with index of 0, and then free the chunk again. And then now we're going to malloc again. So after this malloc, the index of the malloc will be 1. Index of pointer, put 1. And then we're going to do edit, P1. And here we want to put the, the got entry of function malloc. And remember that we need to wrap this in little endian. After that, 2 times malloc. And remember that here we got the pointer with index of 2. Malloc peel again. And then here we got index of pointer with just 3. And also this is the victim pointer. Last but not least, we will edit the pointer with the symbol of function win. Nice. Now we successfully changed the got entry, replace the entry of malloc with the value of function win. In the end, we need to trigger it. I'm going to put here trigger. So this time I will not use interactive mode, but I will just trigger it directly. So what I need to do is to malloc again. Actually, let me just write the interaction over here so that we can output the winning stage. So I'm gonna just write malloc with the size of 8, and then I'm gonna print whatever that I receive from this message. So the reason why I put 2 receive line over here is because by looking at the code, the vulnerable service, I know that the vulnerable service will output 2 lines of information, and then the second line will be the win message. And before that, I want to make sure that I have already, to clear up the buffer, which is the input that we receive from the service. Receive onto. And of menu. Okay. Now let's try to run it. There is an error. It says that the stirred object has no attribute. Decode. Yes, of course. Oh, it's supposed to be yeah, because right now when I define at the menu, it's not defined in byte, it's defined as a string. Now let's try this again. Cool. Now we get the you win message. And this message comes from the winning function. Great. We just successfully launched a double free attack.